Welcome to our flipped lesson on the coordinate plane. Here's today's objective. I'll be able to graph points on the coordinate plane. The coordinate plane is sometimes also known as the Cartesian plane, and that's because it was invented by this guy, René Descartes, around 400 years ago. Here are two examples of coordinate planes, and we'll learn more about those in just a few minutes. The reason we're going to spend some time on the coordinate plane is because it's extremely useful for graphing. The coordinate plane allows us to show a relationship between two quantities, two values. For example, this graph shows the relationship between Sam's weight during the months of the year. And for example, we can see that in January, Sam weighed 49 kilograms. In February, Sam weighed 54 kilograms, and so on. This graph shows the relationship between the number of minutes that Sam worked and the number of dollars that he earned. So again, we can see that Sam, in 1 minute, he earned $2, and in 2 minutes, he earned $4. 3 minutes, $6, and so on. This can be really useful for mathematicians and problem solvers because we can use a graph to make predictions. For example, I don't see on the graph how much money he earned in 5 minutes, but if you notice a pattern in the graph, we can make a prediction how much money Sam earned in 5 minutes. What do you think? Sam earned $10 in 5 minutes, and we can see that because the pattern shows us that the next point would be right here, and that tells us that Sam earned $10 in 5 minutes. We'll be working more on graphs later this year. You already know about finding points on number lines. For example, this simple number line, if I wanted to find where 3 is, I just go along the number line to the point 3. I can even find fractions and decimals on this number line. Like if I want to know where 3 1/2 is, I go to 3 1/2, right in the middle. A Cartesian plane, or a coordinate plane, is just, instead of one number line, it's two number lines, with both of the number lines stacked on top of each other so that they meet right where each has a 0. This way, instead of just finding one point going left to right like a number line, I can find a point in 2 dimensions going left to right and up and down. So for example, if I want to find a point that is right here, I can see that that's going 3 left to right, 4 up and down. This also works for more complex number lines. For example, this number line has negative numbers, negative 10 through 10. If I take the number line, make a copy of it, and then again link those number lines up so that the zeros overlap, we have a coordinate plane. To keep these number lines straight in our heads, mathematicians name them. The one that goes left to right horizontally we call the x-axis, and the number line that goes up and down vertically we call the y-axis. X and y. I remember which is which by thinking about a person doing some stretches. If somebody's stretching out from side to side as far as they can, it makes an X. That's the x-axis. Person stretching out is the x-axis. And if somebody's stretching up with their hands, like this football referee, it makes a Y. So that's the y-axis going up and down. Where the two number lines meet, right here, we call the origin. And it's called the origin because that's where you start out when you're graphing. And you may remember that this is the two number lines meet where the zeros are. So we should be thinking about the number 0 for this origin. Finding a point on a coordinate plane is just like following directions on a map. If you wanted to get from RMA to the beach on this map, you'd need some directions, like go down up American Legion Highway, take a right on Revere Street, and follow that until you get to the beach. Mathematicians need directions too. So to get to this point, we need to know that we have to go over 5 and up 3. And mathematicians call the directions that get us to that point ordered pairs. Sometimes we call them coordinate pairs. Ordered pairs are the directions that tell us how to find a point. For example, here's that point, 5, 3, and I've written it as an ordered pair. See the directions? 5 over 5, 3 up 3. Ordered pairs always have a set of parentheses and a comma so we can tell which direction is which. And if we're being very specific, ordered pairs are composed of an x coordinate and a y coordinate. The x coordinate we always write first so that we can tell which one is the x. Remember, the x coordinate tells us how far over we're going to go along the x-axis. So the first number is 5. That's telling us to go over 5. Then we've got a y coordinate, and the y coordinate always comes second, and that tells us how far up or down to go. So once we've gone over 5, we have to go up 3 because the y coordinate is 3. The trickiest part of graphing points is making sure that you follow the directions in the right order. So like if you were again trying to get from RMA to the beach, and instead of going up a couple miles and then over, you went up a bunch of miles, more than you should have, and then over a few miles, you'd end up in the marsh instead of the beach. Big mistake. So we have to make sure we remember which direction comes first. And there are two ways that I remember how to do that. The first is I think about the alphabet. X always comes before Y in the alphabet. We have X, then we have Y. So we always write the X value first. The second way that I remember which one comes first is I think about the history of human beings. People had to learn to walk, going left to right, across the continent. They had to learn how to walk before they could learn how to launch a rocket ship straight up and down into space. You have to learn how to walk before you can learn to fly. Alright, so let's put all that together and graph this point, point A. And point A, the ordered pair for point A is 3, 6. I like to write X before Y, X, Y over it so that I remember which number goes with which direction. And then I want to make sure that my graph is labeled. Remember, X stretching out, so this is the x-axis, and Y stretching up, this is the y-axis going up and down. And to graph this, I start with the x again because x comes first, and my x is 3, so I'm going to go over 1, 2, 3. So I go to right there at 3 on the x-axis, and then I'm going to go up 6 because the y-coordinate is 6. So 1, 2, 3, 4, 5, 6. That means my point A, is right here. And as you get good at this, you won't need to make these marks to guide you. You may already see that we can find this by just going to 3 on the x-axis and finding where that meets the line that goes through 6 on the y-axis. Remember how the most difficult part of graphing points is making sure you follow the right directions? What if instead of doing it correctly, x before y, I'd mix it up and said, you know what, I'm going to go 6 across, so I'd go over to 6, and then I'm going to go up 3, up to 3. Look, do you see how that's a totally different point? It's not the same thing. This is wrong. I have to make sure that I follow the correct direction. and you just learned about the coordinate plane. That's real swell. In the next video, we'll do some more practice with coordinate planes.